In this section, we now have to learn how to use double integrals to find volumes. Back in 14.1, all we really knew was double integration and how we could find the volume. I mean, not the volume, the area, where we will have the double integration of a to the b c d dy dx. Where as you can see here, there will be no function inside like we're used to when we had single integration of an integral, the integral of a to the b, a function, and dx. Now we are adding a function in it of x, f of x, y, or other known as z. And this can also be considered the height. And in terms of finding volume, it will be, in algebraic terms, it will be length times width times height, where this would be the height and this would be our area, or the length times the width, which you can see here, length times width times height. And how I also have it here, the z, basically the z would be the height, and the double integration of dy dx would be the area, or L times W. It's pretty simple to grasp, and I can show you some examples. In the first example, we would have the double integral of 0 to 4, 0 to 2, x squared over x squared y dy dx. We initially had a 1/2 inside, but I took some time away and just put it on the outside, so it would be much easier for us. So we had to first find the integral on the inside right here, which would be, in terms of y, where x would just be a constant, it would just be y over 2 over 2. And then we put back the constant of x in here, which that's how we get this. And then we need to find first all this 2 and 0 on here, which we end up getting 1/2 integral of 0 to 4 of 2x x squared dx, where I could just take the 2 out here outside, and then 1/2 and the 2 cancels out. So then all we're left with is the integral from 0 to 4 of x squared dx, which is just pretty simple now, which is be x squared, x cubed over 3 from 0 to 4, and that would just be 64 over 3. Pretty easy. Now in the second one, I now added the variable y in there. With the double integral from 0 to 4 and 1/2 y square root of y of x squared y squared dx dy. You can see here I flipped from dy dx to dx dy because I have the y's here first. So then we first find, like I said before, the integral inside in terms of x. So then this would just be a constant, so it would just be x cubed over 3. That's why we have this. And then we just have to plug in these two for all the x's right here. It would just be all this. In the end, it would just be the integral of 0 to 4 of y 7/2 over 3 minus y 5th over 24 dy. And so then after this, we now just have to do the integral of dy, or the integral of this in terms of y, which, as you can see here, 7 over 2 and 5 would just be 9 over 2 and 6, and where you have to, like with fraction, it would just be flipped 2 ninths, and this would just be the 6 down here, that's how we get all this. And then we just have to plug in the 4 and the zeros, some algebraic simplification, and then this would be your final volume answer.